Okay, so just while Sam's sitting up, can I have a quick scroll poll to see who is going to be joining us for dinner? Put your hand up. Okay. Great, thank you. I'm going to tell them that. Okay, so just going to introduce my colleague Sam, who's our, among other things, GNMI and Zero Touch Provisioning expert. So he's going to give us a summary of our interop event that we held yesterday, and also a little bit about the technology that we used to test as well.
Testing, testing. Good. Oh, we'll go like this. Okay, my name is Sam. I'm going to talk a bit about Zero Touch Network and GNMI. And I could not start talking about Zero Touch Network without mentioning Big Cache. And in 2016, he published basically something that, a paper that described where he addressed that the network operations was always a trade-off between scalability, efficiency, and reliability. However, he wanted to have the three of them. And in order to achieve that, he defined a set of architectural principles, one of which is my favorite, and one I'll focus on this presentation, which is that all network operations need to be automated. So what makes a system easy to automate? A system easy to automate has well-defined interfaces, well-defined behaviors, and it has a side effect which is very easy to test. So let's assume that you have your network. It is full of network elements. It has various systems on top of it. If each one of these individual systems it has well-defined interfaces and well-defined behaviors, then the whole of your system, the whole of your network has well-defined interfaces and well-defined behaviors. Except this is not usually the case. Usually we have CLI over SSH and we have a human, and these combinations do not make well-defined interfaces and well-defined behaviors. So why is the CLI not easy to automate? Because it lacks transaction management, it doesn't have such structured handling, the structure and syntax of commands keeps changing, it is not programmable. A side effect is it's not very hard, it's hard to test. So some examples of processes that are hard to automate with the CLI. You can achieve automation of these processes. They will come at the expense of extra complexity and costs in operating it. So how do we make this a little bit better? Usually what we see is some middleware. So basically something that is put in the middle. It tries to hide the problem by simulating programmability and increasing complexity. Right? So what I propose is that we use a well-defined interface, GNMI, that uses gRPC, client to server, to solve this problem. So if we decompose GNMI, we can decompose it in three components. The first one is the gRPC, which is the transport, which is a high-performance RPC framework. Then we have GNMI, which is the service definition, which provides the methods get, set, subscribe, and capabilities. Think of them as actions. And then the properties, the leaves, the values, so where we apply these actions to. In our case, we use Yang to define these properties, these data models, and we use OpenConfig to alter the way that we define these Yang data models. So what is the relationship between GNMI and OpenFlow? OpenFlow focuses on the forwarding plane. GNMI focuses on the platform. Many things in the platform that we need, and OpenFlow does not provide. So a while back ago, we've published a reference implementation of GNMI. So basically Golang binaries with examples of get, set, and capabilities, and a target mock to test those binaries against. We then packaged that into a Docker file, and we've placed it together with Faucet. And that Docker file allows us to bring an instance where we can test those binaries, and we can test those binaries against platforms. So yesterday, we've invited a few vendors to test their implementations against this specific Docker file. And I'm pretty happy to say that they all did pretty well. So the three of them have good implementations of GNMI. They do capabilities, get, and set. Subscribe, which is the telemetry, will come after. So what are the next steps? So adding test cases to GNMI in Docker, cyber RFP, implement streaming telemetry, do GNOI for certificate management and systems, and we'll be on the way to have automated methods to provision a platform regardless of the vendor, from factory defaults to operations, which is our end goal. So key takeaway, automation is fundamental for ZTN. GNMI makes better automation than CLI, and we have vendor implementation of GNMI nowadays. Thank you. Any questions?
So you're talking about using streams for telemetry, gRPC streams. And so today, for instance, Prometheus is just doing HTTP pulls for its telemetry. Do you see the use of gRPC streams being used by something like Prometheus to kind of improve its telemetry?
Well, I don't know the inner mechanics of Prometheus, but I would think that this would be very easily integrated with Prometheus. So one additional thing that this sort of streams brings is that you can get updates when they happen, not when you want, right? And I'm sure that this fits within the philosophy of Prometheus. I actually know who created Prometheus. It works back with me in my office, so it should be something easy to add. Yep.
Can you give some example of what type of thing that can be automated using GNMI?
Things that can be automated with GNMI. So GNMI does mostly configuration. There is a set of services that are just like GNMI, but are well defined in exactly what they do. So this is actually GNMI. So GNMI uses OpenConfig to configure devices. OpenConfig is a set of vendor-neutral models that you can use regardless of the vendor that you have, in theory. GNOI is also a set of RPCs within their own services that do things that are more operational. Like, for example, if you want to do certificate management, you can use this certificate management service to do it. You can revoke certificates, install certificates, and so on and so on. If you want to do system upgrades, for example, if you want to upgrade the operating system, reboot the device, you have a specific service that does that. It is a very well-defined service. It is written within the proto definition what is expected of this service. I didn't add it here. And when you call it, it is expected to do that exactly. So these are things that I expect to be covered with GNMI and GNOI. And mostly these, we should be able to do all of this. And this is just a small little piece of typically what happens in a network environment that is very big. Okay. Yeah.
I'd like to add a small detail to the answer about Prometheus versus GNMI. Prometheus is fundamentally it's a pull model, right? It's a scraping. Adding a little bit of detail to the Prometheus versus GNOMI. Prometheus fundamentally pulls data out of the switch. It is it's a scraper, kind of like SNMP, right? In SNMP, you have an NMS that pulls the switch at some interval to extract data from it. That's very nice. It's gotten us where we are today. But with GNMI and streaming telemetry, we have the opportunity to empower the switch to know when it's appropriate to push information. And so, if the CPU temperature is some number, rather than be told that number over and 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 over, you get where this is headed. I can just say I'd like to subscribe to the CPU temperature. Tell me when it changes. So here it's this value, and then if you have a remarkably stable temperature environment, it will never change. So I'll never get an update. Or it'll go up a degree, and then I'll get an update. Likewise, when the fan speed changes is when I want to know what the fan speed is. I don't want to know that it's 3,700 RPM over and over and over again every 30 seconds until the end of time. So that's there's an impedance matching that you can do where you could build a system that took streaming telemetry and turned it into a thing that could be scraped if you had to then deal with some legacy thing that really wanted to pull rather than be pushed changes as they occur.
Thank you.
Yeah. That's why the verb is subscribe in GNOMI.
Thank you.
When you use GNOI to provision certificates, and you're bootstrapping it, so where is the private key generated?
Well, that is actually part of the certificate. Okay. So when we're using GNOI to provision the certificates, where is the private key?
When you bootstrap it.
Right. Where is the private key generated? You have two methods, actually. So during the install, you have the option to provide the private key that will be installed in the device.
And you probably want to be directly connected to it.
Yes. So, right, the certificate management and provision thing is a special case where you're provisioning a platform. You typically do that in a secure environment, right? So you need to be careful where the environment is, where the platform is in that environment. So that is specific to the institution, policies that you run in. But yes, in the beginning, without having certificates, you have an insecure connection. So that's why you need to have a secure environment to make sure that nothing of that leaks.
So you can generate CSRs. Does that mean the device itself can generate its own private key?
You can ask if the device can generate its private key. If it can, it uses that one. But you should have the option to install your own if you wish. Yes. So this is well documented in the proto buff itself. So it should be easy to read that too.
Thank you.